Hello everyone and welcome to the Showcasing Women in Science and Technology event. Today Molly Bell, a technical plant engineer who works at Suez, will be giving a presentation. This webinar is recorded and you will receive an on-demand version within the next 7 working days by email. Later on at the end of this webinar, there will be a Q&A session for your chance to ask Molly any questions you may have. You can ask Molly these questions all throughout this session in the Ask a Question chat box at the right side of the auditorium. I'll pass you over to Molly now.
Good afternoon. Thank you so much for that introduction, and thank you to the IMechE for having me. I'm really excited to be speaking to you all today, and thanks of course our audience for joining us. So my name is Molly and I hold a Bachelor's in Chemical Engineering from Newcastle University. Graduated in 2017, so I'm just over 3 years into my job. I'm a technical plant engineer working in the energy division of Suez Recycling and Recovery UK. I'm a STEM ambassador and mentor, and I'm also the vice chairperson of IMechE Teesside, and that's usually how I get to do events like this, which is fantastic. So to start off, I'd like to talk a little bit about my journey from university into the role that I'm in at the minute. So just before university, while I was choosing what degree to do, I actually came to a Suez site, and at the time they were known as CETA, and I did a little tour of one of the energy facilities, and this was my first time really been exposed to industry, putting on PPE, going for a tour around the plant, and I just so happened to meet the plant manager, who was a chartered chemical engineer. So I picked his brains about his job and what he did and his education and things, and decided that chemical engineering was the one for me. So ended up starting Newcastle Uni in September 2014, and that same plant manager who I met during that site visit was silly enough to give me his email address. So in my first year, I emailed this poor guy like once a month, telling him about all the things I was learning, all these cool things. I was doing my first year, and persistence paid off because he eventually asked for my CV and shared that with the managers within Suez. So I managed to squeeze in for an internship after my first year during the summer, just for a couple of months. Went back to uni for my second year, did a second internship after that, again with the same team I was in at Suez. And off the back of that, I was offered a graduate role as a graduate engineer working in the technical team. So this covered all of the UK, mainly covering key projects, things like that. So I started there in August 2017. And that little picture there just below of me next to my car, that was my very first day at work. And that's what my mum made me pause for on the drive. So it's cute to look back at that now. So I spent just under 2 years as a graduate engineer before progressing into an assistant engineer's role. And then in December of 2019, I was offered the role as a fully fledged TPE based at one of our energy facilities. The energy facility was the one I actually did a tour of before university, so I thought that was amazing that I'd kind of started there and ended up there. And that picture again was my first day as a TPE, again prompted by my mum. So you'll see Suez a lot on there. I've only ever worked for Suez, so I may as well tell you a little bit about them. They aren't very well known considering how prominent we are in the UK and specifically the North East. So Suez are a recycling and resource management company. We serve over 12 million people in the UK and handle more than 9 million tonnes of waste, whether that's domestic waste, commercial or industrial waste. And we do this via a network of recycling, composting, energy from waste and landfill facilities. And that energy from waste division is the one that I work in now. Now, our guiding principle is something that's well known. It's a well-known concept. It's the circular economy. So generally, people come in around the retail and consumption side. So just a general member of the public will buy something, use it, and then when they're done with it, they'll just dispose of it. And this is where companies like Suez come in to harvest, collect, consolidate, and distribute this. Now, this cycle is based on what's known as the waste hierarchy. So what we aim to do, our first choice, is to reuse or repair anything and put it back into that retail and consumption. Following that, we can dismantle things, break it down for parts, or of course recycle. The next step below that is reforming and recovering. So reforming would be, for example, if you wanted to break down plastic back into its oil constituents and then make plastic again from that. That's something that's up and coming. Suez themselves have got something like that. A couple of other sites in the northeast as well. An amazing process, because in reality you might never need raw oil again to make plastic. You could just kind of keep it going in that cycle, so it's very cool. Then you've got recovery. So what we do at Energy from Waste facility, we will recover the stored energy from general rubbish by burning it and produce steam from that, which we can make electricity from and export that to the national grid. And then the last thing, our very least favourite thing, is just when things go to landfill. Now, landfill isn't the end of the world, because obviously you can get gases from that you can use to combust, but that is the very bottom of the waste hierarchy and the thing that we try and avoid the most. So, as I said, Suez are pretty prominent in the UK. So in the south, just thinking about energy facilities alone, we've got 4 facilities, the biggest being Teesside. They take around 380,000 tonnes of waste a year. Surrey Eco Park is a little bit different. So pretty much all of our facilities just take the waste and burn it in a furnace, whereas Surrey Eco Park is actually an anaerobic digester, and we use the biogas and we burn that to create energy. Now, a bit more local to home in the north, we have a few more energy facilities. I'm based at lines 1 to 3, which you'll see up there, which is just at the top of the page. So in the northeast alone, just in this area, we've got 5 lines 1 to 5 STV, and then we've also got Wilton. Wilton's the biggest in our fleet. That takes around 444,000 tonnes of waste a year. And now the Isle of Man, you see that's a kind of a quirky looking one. That was actually used as the set in the film Stormbreaker. I don't know if anybody's seen that. It had Alex Pettifer in it, and that was used as the villain's lair, where he was creating his like neurotoxin thing. So it's really cool to watch that film now, because I can look at all the different parts of plant and be like, oh, I know what that is. So that's our claim to fame. Suez do have a little credit at the end there. So again, sticking local to home, there's just a general map of the northeast. So if you have a think about where you live on that map, STV 1 to 5 is around where that star is there, so that's our lines where I'm based. And in these circles, this is where we get our waste stream from. So if you live kind of in the Northumberland area, your waste is going to go to line 3. If you live in County Durham, your waste is going to go to lines 4 and 5. And if you live Middlesbrough, Stockton, then your rubbish comes to lines 1 and 2. So in perspective then, those 5 lines, we take enough waste every year to fill all 3 of these football stadiums with rubbish. That's a massive, massive amount. Normally, when I get to this slide, I make a comment about how the stadiums are normally full of rubbish, but I really annoyed a passionate Sunderland fan with that one, so I don't tend to bring it up anymore when I'm with a live audience. So as I've said, for an energy facility, we take general waste and we take it and we burn it. So if you think about what you put in your general waste bin every day, no 2 weeks will be the same. Anything and everything goes in, hopefully everything that's not recyclable. So you'll see the composition general of what we call municipal solid waste. It's a really inconsistent fuel. So you'll see that it's made up heavily of paper and card, plastics, metals, all things that can be recycled. This comes in varying forms, so it can be bagged, it can be loose. Massive variations in size fractions. The moisture content changes throughout the year, which can cause a real issue in terms of combustion, because it's very hard to burn something that's wet. We get a lot of incombustibles coming through, so we have glass, metals, that doesn't really burn, it just kind of changes shape a bit and ends up coming out looking pretty much the same as how it went in. And then obviously we have a varying calorific value. So in the same way that food has a calorific value, this waste does also. That's that stored chemical energy in there, and that's what gives us our heat energy when we combust. So this can vary from around 7.7 to 11.5 megajoules per kilogram, and that causes us some efficiency limiting situations. So if you get some waste in your furnace that's a very low CV, and then suddenly a really high calorific value lot is dumped on top of that, you know, your combustion, your flame kind of goes all over the place, and it takes quite a bit of time to settle that down. And then also, as you can imagine, when you're burning those plastics, we get a lot of acid gases coming off that, and that just goes through and corrodes our boiler as well. So that also limits our efficiency quite a bit. So it's a brilliant fuel to use because obviously there's plenty of it, but the varying composition does make it quite a tricky one to use. So an overview then of energy from waste. We have obviously municipal solid waste coming in as our fuel. That stored chemical energy is released via combustion, and then that heat energy is transferred into a boiler, creates steam, goes through our steam turbine, and then turns the generator, so we get electricity from that. That's used to power the plant itself, so anything on plant that requires electricity, we power that from the electricity generated from the process, and then whatever's left, we export that to the national grid. So from the process, we get two residues. The first type is what we call Incinerator Bottom Ash. That just comes from generally burning. You'll see it if you had a bonfire at home. It's just that ash that you've got left. So what we do with that, we send it to a processing facility. They recover the metals from it, both ferrous and non-ferrous, and any fractions that are left are processed and used to make roads and aggregates and things like that. And then we also get another residue, which is our air pollution control residue. This comes from the boiler itself and also our flue gas treatment process, and this again can be treated and then used to make breeze blocks as well. So nothing goes wasted in this process. Now looking a bit deeper into it then, using this handy cartoon, I'll just quickly summarise the process just so you can learn a little bit more about it. So the first step, the waste comes in a HGV or a general bin wagon. They'll come in and they will tip the waste into a massive bunker that we use for storage. Now this bunker has got to be lined because obviously you don't want any, we'll refer to it as bin juice there. You don't want any of that juice kind of leaching out, so that's got to have a special lining to it. And now this hopper, we've got a waste crane just above it. Now this waste crane has two purposes. So firstly, it's used to mix the waste. So I said about that varying composition coming from general waste. It needs to mix it, and the reason for this is so we can kind of get the composition a little bit more uniform in terms of CV and moisture, but also you can get hot spots in waste. So we have a thermal camera that keeps its eye on the waste pit, and if we do see a hot spot, we use the waste crane to break that up and disperse that heat, because we don't want a fire breaking out in that area. The other thing the waste crane does is it feeds our hopper, so it can get about 5 tons of waste in one grab, picks it up and put it into our hopper, and from that it will go down into our furnace. Now this furnace is comprised of a moving grate, which is very similar to like the 2p machines at the arcades where you put your 2p, like a tipping point. It just kind of moves along, controlling the speed of your waste, pushing it through those zones. Now the zones I'm talking about, you have 5 zones along your grate. The first couple of zones are for drying of the waste, because as I've said, it's really hard to burn something that's wet or damp. The middle section zones, they are your main combustion zones. That's where the majority of your flame will be. And then the zones towards the front there, they will be your burnout zones. You wouldn't expect to see any flame through that. Now in that process, you'll see we've got a fan just underneath there. This is injecting what we call primary air. Now that primary air, its main role is to support combustion by adding in as much oxygen as that process would need. At the end of the grates, we've got a drop-off zone, so now any ash that's burnt off will drop off into a bottom ash conveyor. Now this is full of water, so this will quench the ash, because you can imagine it's very hot when it's coming down, and this also allows us to maintain a seal. So this full process is maintained in negative pressure, so we need to keep that hopper full all the time to maintain the seal, and that bottom ash conveyor at a certain level again to maintain that seal. Now once the ash has been quenched, it goes off to one of those facilities I mentioned a moment ago, and the metals etc. are recovered and it's made into aggregate. So any heat then from this process passes up into our boiler. Now in your first section of boiler, that's where our flue gas treatment starts, where you inject ammonia to eliminate any NOx coming through. So that's kind of in that first kind of pass of the boiler. So as the heat goes through the boiler, you'll see that this little twirly thing, this is a very simplified version of a boiler tube. So we've got thousands of boiler tubes in our boiler that obviously has water going through it. And throughout the boiler, we end up getting superheated steam, which is the hottest kind of steam. That then goes through our steam turbine, which turns our generator, exporting electricity to the national grid. Once it's been through the turbine, the steam then condenses down and just goes back into the boiler as condensate and then gets made into steam again, so it's a closed system. We do have losses obviously through drainage, blowdown, etc., and that's topped up through a demineralisation plant. So it's a water treatment plant that just takes general town's water, so what you'd get through your tap at home, and it produces deionised water, demin water, and that goes into our boiler and steam turbine. So you'll see when you combust things, obviously you get like an ash coming up in the smoke. Now this ash settles on our boiler tubes and this plays havoc with our heat transfer. As you can imagine, the heat transfer surface area gets covered with this ash and we don't get the transfer that we need. So we have a number of boiler cleaning systems. These systems knock the ash off those tubes and it goes down to this system here, through and down, and mixes with our air pollution control residue, which I'll touch on in a second. So once the flue gas has been through the boiler and we've extracted as much heat as we can, we then enter our flue gas treatment system. Now the first part of this is made up of a reactor. This has two jobs. The first thing is it injects water and that cools our flue gas right down, ready for the bag filters. And we also inject hydrated lime and activated carbon. Now the lime is to get rid of our acid gases, so HCl and SO2, and then your activated carbon gets your heavy metals and your dioxins and your furans. The flue gas then will go through a series of bag filters, so this does exactly what you'd expect. There'll be about over 1,000 bag filters, which just look like a very long kind of cylindrical sock. And they just trap any solids trying to come through the flue gas, any dust, any residues. So all this residue that comes from the bottom of the reactor, the boiler and the bag filters then goes off, and that's our air pollution control residue, which goes off to be made into breeze blocks. And then our flue gas, which is now clean because it's got no solids in it, will go up through our induced draft fan, which is sucking everything through this process, and then up through our stack. So in that stack we've got emissions monitoring, which is continuous, so as long as we're burning waste we are monitoring our emissions, and the reason for that is that we are very tightly regulated by the EA in terms of what we can put into the atmosphere, but this flue gas treatment system does a fantastic job in catching any of the nasties and making sure what we're putting out is compliant and safe. So that was just a little bit of an overview. I hope you found that interesting. I obviously find it really interesting. So a little bit on my internship then. So how did I get my internship? I spoke about that. I just pestered somebody for like a few months. I didn't apply directly. There was no, application process, interview. It was just pester power. Why did I want an internship? So I wanted exposure into the industry, something to put on my CV. But also I was really desperate for a taste of engineering because before I started my degree, I didn't really have much experience other than that tour that I did, so I thought I'll give it a go early and see if I actually like it, because if I don't, I can start looking at alternatives such as law or finance. So during my internship, this was to give me a taste really into what the business does. I was only there for maybe just short of 2 months over the 2 years, so after year 1, 2 months, after year 2, 2 months. So during this time, I kind of worked on as many projects as I could, just getting a taste for things. So key projects for me included waste mixing modelling, again trying to optimise the mixing of that varying waste fuel. A leachate spill incident, that was exciting to investigate a real incident because again the Environment Agency really tightly regulate the storage of leachate and things, and we had an overpressure which caused a bit of a spill, so we had to go down to Cornwall to investigate that. And then EFW water balance, that was just a case of getting to know the plant systems, seeing where we use water, seeing where we waste water, and overall reducing those losses. So water is expensive. So the pictures there, just to give you an idea, I am you can kind of see the crane in the background, just to give you an idea of that. So that's the crane working in the waste pit. Now it looks a bit grim and a bit dirty, but that will be mixing, or it will be feeding the hopper. It does smell in there, so I don't know why I'm smiling so broadly. And then the other one is just me actually driving the waste crane, but I only got to do that once because I hit the wall a couple of times. So I only do it in an absolute emergency when I need to. So after university then, and off the back of my internships, I was offered a place on the graduate scheme, which was exciting, exactly what I wanted. I was working for Suez. I loved it. I loved the people I worked with, and I was keen to join them after I graduated. So this was a bit different to my internships because I was with them for the 2 years, and it was very structured. The one for me was IMechE accredited, which was great because that was relevant to my discipline. And again, it was over 2 years. So during that time, I worked on projects all throughout waste management. So I spent a little time in landfill, a bit of time in processing. So I was working on a project for odour control, which again is very tightly regulated by the Environment Agency. And then again, working in energy from waste, mainly in the north. During the scheme, I also ended up doing some placements. So I spent some time with our environment team to learn a little bit more about the compliance and legislation. Also worked with the health and safety team to look at both process safety and occupational health and safety. I spent about a month with the ops team actually on shift, so just learning about how the operators run the plant to its spec, and that included doing night shifts, which I did not enjoy very much at all. And then lastly, I spent some time with the maintenance team, just learning what they do and getting appreciation for their role. And then with the graduate scheme, obviously came some training. So I completed my IOSH, which is kind of the start of health and safety training, just before you do your NEBOSH. I did my confined space training, which allows me during periods of outage to go inside the process and have a good look about. And then just some general technical training as well, just to improve my knowledge of the process. So I spent 2 years on that, had a great time working with that team. And then in the December, I was offered a role as the technical plant engineer at lines 1 to 3. So what do I actually do as a technical plant engineer? So I'm responsible for the operation of a key Suez energy facility. Now that means that so a lot of our facilities might be owned by the council, or they might be owned by stakeholders. The lines I work at, lines 1 and 2, they are just owned by Suez, so any revenue that we get from exporting electricity, taking waste, that is all for us, and that's what makes it a key facility. I'm responsible for a lot of contractor management, so I'll get given a service contract to review, working with procurement, and then if we get contractors coming to site, I'm responsible for keeping an eye on them, making sure they're working as per the scope and working safely also. Mentioned this a lot, but ensuring compliance with EA regulations is really important, both from the emissions point of view and also our IBA. This is pretty standard for anybody on a site, but I'm responsible for my own health and safety and the health and safety of others from an occupational point of view, but also I'm involved in a lot of hazard studies, so risk assessments, HAZOPs, things like that. Process optimisation is a massive part of engineering, so that gives us opportunity to basically save money somewhere. So as I've said, in our flue gas treatment, we inject lime to combat those acid gases. There was a project just last year to optimise that lime injection to make sure that we were putting in the right amount so that we were still able to comply with our emissions regulations, but also to make sure we weren't overdosing that lime and just wasting money. During outage periods, I have to complete a series of inspections. So an outage is when we bring the plant offline to do some maintenance and to do some inspections, make sure everything's okay. And that's what I was doing in that picture there. So I had to put about 10 buckets of that pink dye through that tiny hole, which took ages. And that pink dye is a fluorescent dye. So this bit of ducting is just after our reactor, just before the bag filters. Now what that dye does, when you've got your ID fan on, you put the dye in and it will suck through into the bag filters, and then you open up the tops of the bags and you'll take a UV torch and kind of look in each bag. Now bear in mind there's over 1,000 bags, so it's quite a big job. You'd look in with your torch, and if you saw some of that fluorescent dye had come through the bag, that gives you an indication that that bag has failed and it's no longer filtering out any dust, so we change that bag out. So it's just a way for us to inspect the bags, because normally if you look in with a torch, you've got no chance of spotting any holes. By the time you know a bag's failed, that's when our dust emissions are creeping up, and we have to isolate a compartment and see if we can find the bag that is holed. And then lastly, problem solving, again, massive part of engineering. If something happens that brings us offline or causes an issue, it will absolutely come to me to find out what happened and why, and how do we stop it from happening again. So for example, we had a transformer failure not too long ago and it brought the full site offline. So we had to work out what had happened and why it happened. So we worked out that we just had a short on the transformer windings. What can we do to make sure it not happen again? So we did a root cause analysis and now we've implemented a solution and we're closely monitoring the system. So a typical week for me. This looks like a pretty busy week, but I've picked a good week to kind of show off kind of what I'm doing. So you'll notice there every day at 9 o'clock I have a daily review meeting. This gives us a chance to review plant performance over the last 24 hours, have a catch up with the operators, make sure there's nothing creeping in that might bring us offline. On Mondays every week we do an NOC review. Now NOC is a normal operating condition. This allows us to have a look at plant performance over the last week, but at specific variables such as reactor differential pressure, furnace temperature, things like that. And it's often a chance for us to preempt if something's going wrong, if something's starting to trend a little bit out of its limits, and we can catch things early and make sure it doesn't bring us off. Process monitoring is a massive part of my job, so every week we do sampling of our boiler water systems, so what's coming out of that demon plant, what's going through the process, and we have those tested at our lab. So I'll review those results and maybe make some changes to our boiler dosing systems to make sure that we have a good pH, low conductivity, things like that, keeping the system healthy by looking after that water. There's a few key project meetings scattered about, so you'll notice there we've got a carbon capture project going at the minute. So I can't say too much about that, but if you'd like to know more about what Suez are doing for carbon capture, we're working with Net Zero Teesside. Just Google Suez carbon capture and you'll see our press release. But that is a massively exciting project for me to be a part of. Again, a couple of contractor reviews dropped in there, and then also commissioning of a new install that we put in last week. So another massive part of my job, and this is probably one of the favourite parts, this is volunteering. I absolutely love volunteering. So obviously I do talks like this pretty regularly. I'm a STEM ambassador. I do a bit of work with the IMechE. Now this is something I would definitely recommend to anybody, whether you are in early career or a student. Since doing this, my confidence has shot up. I can do talks like this and I was only a little bit nervous before coming on, whereas before I might have been really nervous. My communication skills have vastly improved. I can explain this process, this technical process, to some little primary school kids in a way that they understand and they enjoy learning about it, which is so lovely. I have the opportunity to inspire. So this team here, they're just in the bottom corner picture with the certificates. They were a group of guys who weren't really that bothered about the competition that we were in. They didn't really think they stood a chance. And, we coached them through the engineering education scheme and they ended up winning the top prize, and that was such a proud moment, for those guys to think that, they didn't stand a chance and they ended up winning it because of the hard work they'd put in to their project. It was a fantastic day. And then lastly, of course, it can help you with your chartership application and also your personal development. So if anybody asks, I would definitely recommend volunteering. I really do love it, and I've missed it during this pandemic. I've missed having the school groups to site and giving them a tour. So do I like my job? I hope it sounds like I do, because I absolutely do. Although in this picture I was absolutely so nervous in there. So what I'm stood on there is our moving grate that I mentioned inside the furnace during a period of outage. So you can see there, it's very unsteady underfoot, and I put my thumb up, I think, just to kind of hide how nervous I was being in there. But of course I love my job. So I get to support and host educational outreach activities, which I've said I absolutely adore. I work with Suez to help the local community. So we are based in Teesside. Our community is Teesside. So we do a lot of charity work. We do beach cleans. We do food drives. It's fantastic. I've had some really great opportunities for experience and learning in my internships right through into my technical plant engineer role. And the people I work with are really lovely. I know a lot of people say that, but I have made some friends for life here, which is fab. And I feel challenged every day. And that is mostly in a good way, because a little bit of pressure just keeps you going, doesn't it? So, based on my experience, and I have helped recruit engineers myself, graduate engineers, I thought I'd give some advice for students in early career. So when you're applying for internships and graduate schemes, it is quality, not quantity. We had a guy who applied for our graduate scheme and he didn't even bother to change the company name in his cover letter. So straight away, we were no longer interested in his experience and education. He was no. So just make sure you're really tailoring your applications. Next, do your research on the company with whom you're applying for the job. It's always lovely to hear in an interview or in your covering letter that you've been on our website and just had a little look at what's going on in the minute. It shows that you've put effort into your application. No advert doesn't mean no job. So there wasn't really a graduate role here when I ended up getting my role, but because I inquired and pestered, I ended up getting a job off it. So, go on LinkedIn, connect with some people, or just send a letter out to local companies saying that you're interested in some work experience. It doesn't necessarily need to be paid, but yeah, don't just limit yourself to the people that are advertising for jobs. Be open to different industries and roles. So when I came into uni, I had no idea what I wanted to do or what I wanted to be. So I was pretty open to what I wanted, to opportunities. Whereas some of my university friends, they came into the degree and they were absolutely adamant they were going to work in the oil and gas industry. They were going to work for Exxon, and they didn't get there. They didn't get the job, they didn't get the work experience, and they were disappointed. So just be open to it, because if you're dead set on going into oil and gas, if you don't get in as a graduate or an intern, you can always go in later in life once you've got a bit of experience elsewhere. So, just be open, and then be mindful of what you put on your CV as well. So we would not expect to see people coming out of university with a bachelor's or master's who have areas of speciality. Like, if you've just done your degree, it's unlikely that you're going to have a specialism or an area of expertise. So don't put that, because the people who are reading your CV will probably just roll their eyes. So on the job, get out of it what you can, but don't overload yourself. So I've done my best to make the most of every opportunity that I was presented with, but of course I always remembered that I had job role objectives to deliver. So I've always done that. Ask questions and learn as much as you can. So it's amazing how many contractors will happily explain to you what they're doing, why they're doing it, if you just ask them, kind of nicely. So really ask those questions and learn. Nobody is going to judge you at all for asking a question. And then lastly, you are not above anything. So what I mean by this is, if you are a graduate or whatever coming into a graduate scheme, congrats on getting your degree. But we've experienced people in the past who have turned down tasks and roles because they think that they are too good to do that. And I'll tell you now, that attitude is just not the way to go, and you won't do very well in that company at all. So, try and take that on board if you can, and just be open to everything that they're asking you to do, because it'll always be to support your learning. So, if you like the sound of Suez, this isn't a bit of a plug, but I just thought I'd say in case I'd kind of spiked your interest. We do offer a graduate scheme with a biannual intake, so the next intake is 2022, and we advertise on our website and Milk Round, and we also might contact certain universities, to try and advertise directly to their students. And the benefits and packages were great. And again, you'd be moving all over the business like I was, just to increase that exposure. And I myself, if you like the sound of me, I am currently seeking an intern to start in summer 2021. The duration of this is to be confirmed, but you'll be based at Teesside with me and doing pretty much what I do. So general engineering, process monitoring, optimization, working on an outage, etc. So if you're interested, get in touch with the IMechE and they can put you in touch with me. Or of course, just drop me an email at molly.bell@suez. But in my role, it is very general. I've got a chemical engineering background, but I'm regularly doing mechanical engineering in the boiler, electrical engineering with our generator and our transformers, process control. It is a really, there's a lot of opportunity to do all kinds of different things in this role. So if you fancy that, drop me an email. I think that's it. That's me finished. So thank you all so much for your time. I hope I wasn't too fast, and I hope that you found the process interesting. I find it so interesting myself, energy from waste. So if you've got any questions, please feel free to drop me an email, or of course use the attendee question box at the side. So yeah, thank you so much.
Thank you, Molly. That was a really interesting presentation, and it was nice to have an insight in what you do and what you do at Suez. It's time for the question and answer session now. Thank you for all the questions that you've sent in. I'll ask you the first question that's popped up, Molly, now. Being a female in a majority male workplace, have there been any challenges that you've had to overcome?
I don't want to put anyone off, but yes. Now, when you come into a male-dominated environment, and it is, the waste industry, there aren't a massive amount of women working here. Out of the technical plant engineers, we have, say, 10 facilities, and I'm the only female engineer that's actually based at a site. So the only difficulty it kind of brings that I've experienced is that people have a tendency to assume what your job role is without speaking to you, which is a bit of a pain, but so long as you just introduce yourself very clearly. So, hi, I'm Molly, I'm the technical plant engineer at this site. You'll have no trouble going forward, but it's 2021, women in engineering, there's plenty of us around, it's not a new thing, and if you've got any trouble at all, you've just got to hold yourself strong and make sure that you're here and you know your stuff and you're there to stay.
Thank you for answering that, Molly. Another question that's come in is, why did you choose chemical engineering?
Ooh. So for me, at the time when I was looking, I'd not long finished college and I had a real interest in chemistry and maths. So when I was looking at all the engineering, so the main ones I looked at were electrical, mechanical, and chemical. Those were the main three that I looked at. It just seemed to me that chemical was quite broad and it had things that I was more interested in. So a lot of the modules were centred around, looking at the environment, general process design, things like this. Like at the time, I felt as though mechanical engineering, electrical engineering were very specific. But now, when I'm doing a project, I can be quite fickle with my engineering. So with the transformer issue we had, I was thinking to myself, oh wow, I wish I'd done electrical engineering because then I'd know what was going on. And then if we do something in the boiler, I'm thinking, oh, I wish I'd done mechanical engineering. So, I think I picked the right one in the sense of I enjoyed my degree and I enjoy the job I do now. But that was why I went for it. It just interested me at the time. But really, it's a big decision to make. Because how are you supposed to know when you're just coming out of college and you're making a decision that's going to impact the rest of your life? So try to pick something that would keep my options open and keep things quite broad. And as you know, with engineering, that's the case all the time. Law firms look for engineers, finance firms look for engineers. So it's a really good way to keep your options open.
Thank you for that. Another question is, do you have an example of when you faced a difficult challenge?
Well, yes, this is probably linking back to when I said every day is a challenge, normally in a good way. So I've found that since becoming a fully fledged engineer on a site, I'm really responsible for protecting the site from, getting ripped off basically. So I've discovered recently that I have a real issue with challenging people. It makes me a little bit uncomfortable to have to point out when somebody's maybe not done a very good job on the job we've asked them to do, or they're trying to rip us off a bit in terms of their pricing, because I don't love confrontation. So what I've done is I've managed to find a little bit of a mentor in that sense, and what I do if I've got something where I need to challenge somebody, I will run through the situation with my mentor. They'll kind of explain what they would do, and I kind of hash it out with them first, and then I'll be able to approach that person and feel more confident in challenging them. And it's something that I'm going to have to get better at, because I've realised recently sometimes, people, they do try and rip you off or pull the wool over your eyes and things, and as an engineer working for the site, you can't really let that happen. So I'd say that's my biggest challenge at the minute is confronting people, and getting the most for our money from contractors.
Thank you for that. There is another question on how do you know the composition of waste/rubbish?
Oh, yeah. So For that, we have some poor souls that come to site. They will take a sample from the waste pit that aims to be representative of the full pit, and they will literally have that in front of them, and they will just pick out stuff and like by hand and just put it into categories of materials. So it sounds like an awful job, and I think we get that done maybe once or twice a year because it just gives us an idea of how waste is changing. So we were a little bit concerned a couple of years ago. Well, I say concerned, there was this big push on recycling, and we had to think about how will people recycling more impact our waste stream. So we had to kind of do a little bit of an assessment to predict how the calorific value of our waste would change if people were putting in less cardboard, less paper and things like that. And having that assessment done of the waste composition every so often just gives us like a chance to kind of build like what is waste looking like over the last couple of years, what do we think it'll look like. But yeah, it's not a very nice job because like I say, it's pretty much done by hand, picking through people's rubbish.
Thank you for that. Another question has just come in. Have you noticed a change in waste items since the pandemic?
Yes, so we did get, this is quite funny, more aluminium coming through because people didn't have room for their cans in their recycling bin because obviously everyone was at home enjoying the nice weather over the summer. But, in terms of waste specifically from the pandemic, so we don't take any bio waste because the temperatures in our furnace, we only get to about 1,000 degrees, and that's not hot enough to burn anything, like bio waste or whatever. So we don't take anything like that, but we have recently started taking some non-hazardous pandemic waste, which is like comes from the testing centres, I think, but it's just like the wrappers off the used tests and things. We don't get anything with human parts on or whatever. But more people at home, so they might be generating a bit more waste. But yeah, I'd say that's the thing we've seen more recyclable material coming in through their general waste because they just don't have the room for it in their recycling bin. But you see that at Christmas as well. People are celebrating more, so you tend to see a lot more, like cans, like glass bottles, things like that coming through.
Thank you. We might have time for one more quick question. If you could change any of your career decisions, what would it be and why?
Can you say that again? Sorry, what was that?
Sorry. If you could change any of your career decisions, what would it be and why?
I think I've been pretty fortunate with the way my career's gone because I've never had to apply for anything. The internship came off the back of me pestering this poor guy. My graduate scheme came off the back of the internship, and this role as an engineer came off the back of my graduate scheme. The role was available, and I kind of slotted into it. I think what I wish was, I didn't know that I was coming to be a site-based engineer. So when I was in the graduate scheme, I worked in a technical team that covered UK projects. So I worked all over the country, covering stuff for different energy from waste facilities, different landfill sites, things like that. And I got exposed to a lot in the business. And then when I moved here, I've learned so much and I absolutely love it. It wasn't necessarily a planned move, but I wish I'd made the most of being in that technical team because I thought I was kind of going to be in that forever. But that doesn't mean that I regret coming here because this has just been a whirlwind opportunity. Because when I first started, I was really scared because I thought, I don't have the experience to do this. And I was really thrown at the deep end, and I've had a really brilliant time, and I've just learned so much. So the only thing I wish I'd just made the most of what I was doing at the time, because the time flies by.
That's great to hear how passionate you are about what you do. Thank you so much for answering everyone's questions.
That's no problem at all. Thank you so much for having me.
I hope you've all enjoyed this webinar. Thank you for attending today.